In the previous video we had a look at how to do angles in the Cartesian plane for trig, how to identify the quadrant. Now we get to what we call tick and draw questions, and these questions you can identify if they give you two bits of information and they say without the use of a calculator and with the aid of a diagram. Alright, they don't have to give everything of this, but it's often how we ask them. So let's look at an easy example. If cosine of theta is 4/5 and theta lies between 0 and 180 degrees. So that's one bit of information, two bits of information. They say calculate without the use of a calculator and with the aid of a diagram the following values. And then they say calculate tan squared of theta and sine of theta plus cosine of theta. Alright, now I just wanted to make a note because for these you're going to draw triangles. The triangle is always going to be like this or like this or like this or like this, never here. Alright, never there or there or there. It always starts there and goes down with the 90-degree angle over there. Right, so let's have a look at this one. We have a lot of information here. We know that cosine of theta is 4/5. Okay, cosine of theta is 4/5, and this is our cos table. We know that cosine is positive. This is positive, so that is in A and C over there. We first want to identify which quadrant we're working in. Right, and then we are told that theta lies between 0 degrees and 180 degrees. Okay, that is from 0 to 180 over there, so it's either there or there. So we're going to work in the first quadrant, and our triangle is going to be drawn like this. And I'm going to do this sketch pretty big because this is what your teacher will mark. Alright, so already we have a bit of a better idea where we're going. This is angle theta over there from the positive x-axis to the radius. Alright, we know that this is the radius, this is x, and this is y. Okay, cosine is positive, but we know exactly what the ratio is. Cosine is 4/5. Shade your rear, cos x raise tan your exterior. Right, so x must be 4 and r must be 5. X is 4 and r is 5. Right, now we just want to work out y. Now, if you don't know these questions very well, you might get stuck here. But remember, in the previous video, I told you that the theorem of Pythagoras applies to these triangles as well. This rule always applies. Now we said that r is 5 and x is 4, so I'm going to substitute that in. r is 5 and x is 4 plus y squared. Right, so that's 25 equal to 16 plus y squared. That's going to give us 9 equal to y squared. Now, when I take the square root on both sides, I must say plus or minus. Right, this is due to the difference of two squares. Your teacher may have taught you using that or this shortcut. Both ways are correct. So this is plus or minus 3 equal to y. Right, so we know that r is 5, x is 4, and now we need to determine whether y is positive or negative. Okay, now even if we look at the sketch, we use the sketch to determine this. Y is clearly positive on this sketch. Okay, it's on the positive y-axis, so it must be positive 3. Right, so y is positive 3, and I'm just going to group them together like that. Now you'll notice I haven't actually answered the question. The question said determine the values of this and this. Now I'm going to start with answering those questions. Okay, the first one here is tan squared of theta. Right, now we all know that this is tan of theta squared. Shade your rear, cos x rays tan your exterior. Now this is tan, so I'm going to square it to get tan squared. We said that y is equal to 3 and x is equal to 4, so this is 3 over 4 squared, and that gives me 9 over 16. That's my final answer for question 1. Right, question 2. We want sine of theta plus cosine of theta. Shade your rear, cos x rays tan your exterior. Right, y is equal to 3, r is equal to 5. X is equal to 4, r is equal to 5. We wrote them down over there. Alright, and then we can type this into our calculator, but if you remember, denominators are the same, so we can add the numerators. 3 plus 4 is 7, and the denominator stays the same. That's our final answer. Right, so that is our first tick and draw question. Let's look at another one, a little bit more difficult. If sine of theta, 13 sine of theta is equal to negative 5. So we start with this bit of information. And let's just read the question like we should. And tan of theta is positive. Calculate without the use of a calculator and with the aid of a diagram the value of cosine of theta plus sine of theta. Alright, so we're going to start with the first bit of information. The second bit of information is that tan of theta is positive. Alright, we want to get sine of theta alone because we want to know whether it's positive or negative. So I'm going to divide by 13 on both sides, and that gives me sine of theta equal to negative 5 over 13. Now, just keep in mind that this could also be negative 5 over 13 or 5 over negative 13. Alright, and the way that the sketch is drawn will determine whether x, y, or r can't be negative, but whether x or y is negative. Okay, so we know now that sine is negative. Sine is negative in which quadrants? It's this quadrant and that quadrant. And tan is positive in this quadrant and that quadrant. So we're going to draw a triangle in the third quadrant. Alright, so we need to draw a nice big-ish sketch. It doesn't have to be huge, but your teacher should be able to see what you're saying. Alright, so I'm going to draw over here, and because I know it's in the third quadrant, I can sort of make my positive y and positive x-axis a little bit shorter. Right, and that's going to be our triangle there. Right, so we have sine of theta is equal to negative 5 over 13. Shade your rear. Right, so in this sketch, r is either positive or negative because the answer was negative, but r can never be negative. So r over here is positive 13. That means that y over here must be negative 5. Right, so we have x, which we don't know, y equal to negative 5, and r equal to 13. Now we're going to use the theorem of Pythagoras to work out x. So we know that r squared is equal to x squared plus y squared. R is 13. X is what we want to know. And y is negative 5 squared. Right, that's 169 equal to x squared plus 25. That should give me 144 equal to x squared. Right, take the square root on both sides. Remember plus and minus. So that's plus or minus 12 equal to x. And now we just need to determine based on the sketch, is x positive or negative? It's negative, so x is negative 12. Right, over there. So x is equal to negative 12. Okay. Then, we haven't actually finished the question. The question said, calculate the value of cosine of theta plus sine of theta. Okay, so cosine of theta plus sine of theta. Cosine, shade your rear for sine, cos x rays for cosine. Right, and remember we said that x is negative 12, y is equal to negative 5, and r is equal to 13. Okay. X is equal to negative 12, r is equal to 13. Y is equal to negative 5, and r is equal to 13. That should give you negative 17 over 13 as your final answer. One last question. This is from exercise 8 on page 82. I'm going to do question C. Alright, it says if cosine of A plus 3 is equal to 0 and A lies between 180 and 360, determine with the use of a diagram. Alright, so first we need to look at 5 cosine of A plus 3 equal to 0. We want to get cosine of A alone, so we're going to kick the 3 over, it's going to become negative. Then we're going to divide by 5 on both sides, and that's going to give me cosine of A equal to negative 3 over 5. We don't know which one's actually negative yet. Right, and then between 180 and 360. Okay. We're going to draw a cos table. This can be very rough. And you can say, okay, cosine is negative. Cosine is negative over here and over here. And then we want the angle to be between 180 and 360, which is over here and over here. So we're going to work in the third quadrant. Okay. So we're going to draw a rough sketch over here. And this should be pretty big, preferably with a ruler over there. Alright. We have cosine of A equal to negative 3 over 5. Shade your rear, cos x rays tan your exterior. Right. So, I just want to point out this is the angle A. For anyone who's unsure, A is measured from the positive x-axis to the radius. Alright, so x, y, and r. X should be negative 3 because it's on the negative x-axis. Y is what we don't know, and r is always positive, it's 5. Right. We're going to work this out using the theorem of Pythagoras. R squared is equal to x squared plus y squared. R is 5. X is negative 3 plus y squared. Right, that's 25 equal to 9 plus y squared. That's 16 equal to y squared. So y is either positive or negative 4. And now, based on our sketch, y must be negative. Alright, so y is negative 4. So we have x equal to negative 3, y equal to negative 4, and r equal to 5. Now we're going to answer our questions. Number 1 says tan squared of A. Alright, shade your rear, cos x rays tan your exterior, and the whole thing is squared. Y is equal to negative 4 and x is equal to negative 3 squared, and that's going to give us 16 over 9. Right, let's look at the second question. We want sine of A over cosine of A. Now I'm going to do this one a little bit different. This is sine of A divided by cosine of A. Shade your rear, cos x raised tan your exterior, tip and times y over r multiplied by r over x. The r and r cross cancel, and that gives me y over x left. Alright, you can do this by substituting in here or here or here. I just want to show you that the r's can cancel out. And then y is equal to negative 4 and x is equal to negative 3. So that gives us 4 over 3 as our final answer. You need to be very careful when working in the third quadrant, because sometimes you'll get information like this. Tan of theta is, let's say, 4 over 3, but then it's actually negative 4 over negative 3. You need to be very careful with that. If you have any questions, leave it in a comment down below or WhatsApp me.